Good morning, folks. This is Mr. Dan coming to you from the Landscape Design Classroom, and today we're going to talk about understanding soil and land use. The main idea here, what are the soil properties that influence how land can be used, and where can I learn about soils in my area? Soil properties influence how land can be used. So steep, long slopes are suited for a ski hill, and large flat fields are suited for crop production. Sometimes, though, you definitely will find crops on steep hillsides because we are definitely trying to maximize the use of our land here in the United States. So you will find crops in some really weird places. So what are some factors in land use? Usually expressed, or slope, which is usually expressed as a percentage. To calculate, you take vertical drop divided by horizon distance and multiply by 100, which will equal the percentage of your slope. So on the picture to the right here, we have some erosion going on after a forest fire, and this would be a disruption to vegetation on a steep slope. Soil texture, determined by the size of soil particles, proportion of sand, silt, and clay. Affect drainage, water holding capacity, nutrient holding capacity, fertility, permeability, and more. And the graphic here on the right shows the size of various soil particles, with sand being your largest, down to silt, and clay being your smallest. So a lot of people think that's actually reversed, but clay is actually the smallest particle you will find within soil. Just because it becomes super duper dense, people think that would be the largest, but it's actually the smallest. And because sand runs right through your hands, that's actually a lot larger particle. So moving on to organic matter, influences soil structure, nutrient supply and capacity, water supply ability, permeability, drainage, and erosion. Added when plant and animal residue decompose, and measured in percentage content. So what is organic matter? So organic matter can be pretty much like animal bones melting, feces, plant residue after it dies. So it can actually be a lot of different things. So moving on to topsoil, provides the fertile root zone for crops and plants. Typically, you want this to be about 6 to 12 inches for good grass growth. Usually more permeable than subsoil, allows water to filter in and roots to penetrate. Moving on to the subsoil area in the middle over here. That is, the area is about 12 inch to 35 inch deep area in the ground. So you have drainage and water holding capacity. Too tight, it becomes waterlogged, so it becomes really compressed. Too open, dries too rapidly for plant growth. And this is typically the area that you're gonna have some of your larger plants growing in. So if you're putting in some trees and whatnot, they're gonna grow into that subsoil and even deeper. So how is soil formed and changed? This includes minerals, organic materials, and living organisms, alive with biological and chemical activity, formed over time by natural processes, influenced by climate, slope, rainfall, and biotic activity, and can be changed by natural forces or human activity. So disasters are going to play a part here. Floods depositing sand, sediment, and uprooting plants. Droughts leading to erosion and use of groundwater for irrigation. Forest fires destroying trees and allowing disease. And some other things such as avalanches, earthquake, hurricane, tidal wave, tornado, and volcano. So as you see on the picture on the right, it looks like at some point there was probably a flood going through here, or maybe even a small earthquake or something, but the hillside here is eroding. So what about soil surveys? These have been done by the USDA since 1890, used for technical assistance to farmers and engineers. And recent surveys are much more accurate and detailed. We actually do soil reports here in class, which is part of our NOCTI exam. So we will be taking a look at these in class. Surveys since 1957 include estimated crop yields, land capacity, soil woodland interpretations, rangeland interpretations, engineering use, community planning interpretations, suitability for drainage and irrigation, and suitability for wildlife and recreation. Some of the soil maps you'll see will include soil property changes over short distances, soil subject to flooding, soil is not suitable for foundations, soil is unsuited to septic tanks, and useful, but they are useful for farmers, forest or agronomists, engineers, contractors, land use, and community officials. So soil maps are hugely important because it actually helps with a lot of different things. I know here in Pennsylvania, insurance companies use soil maps to determine if a house is going to be built in a flood zone or if a house isn't a flood zone to see what the cost of insurance would be for that home. So soil maps are used by a ton of different people. So that is the end of my presentation. If you have any questions, give me a call down here in the landscape design classroom. But I appreciate your time, folks, and have a great day.